So we're going to be learning today what a general term formula is for arithmetic sequences. We're going to continue to solve problems with arithmetic sequences, but the complexity of those problems is going to increase. So we're not going to learn something new here and do the same problems we did yesterday. We're going to learn something new and apply it to what we learned yesterday at a higher level. And we're also going to be looking at graphs of arithmetic sequences. So to begin with, and we talked about this at the end of yesterday's lesson. I just finished talking about it now. That's how important it is. We're going to talk about it a third time. So I have this sequence that's 10, 16, 22, 28, etc. And sometimes when I transpose information from your handout to my smartboard screen, things don't go all perfectly. Can you confirm that those are the right numbers? Okay. So question A said, what is done to the first term, which is T1? What is done to T1 to get the second term, which is T2? And I know that you know the answer is you add 6, right? 6 is added. Okay, let's go add 6. What is done to the first term to find the third term? Well, to go from 10 to 22, you add 12. But what I would like us to do is back away from the specificity of these answers. I don't want specific answers. I want a general answer here. What is it you do to the first term to get the second term? Well, you add 6 because 6 is the common difference, right? So the better answer here, the one that's a general answer, is you add 1 common difference. D is the common difference, right? Which is 6. What is done to the first term to get the third term? Well, you add 2 common differences. And I want you to notice, I'm not going to write this down because it'll get too confusing, that if you're after the second term, you take that number 2 and subtract 1 to get how many common differences. If you're after the third term, you subtract 3 minus 1 to get 2 common differences. So you're adding n minus 1 common differences. Okay. Remember from yesterday, n is where the term is. So if n is 12, it's the 12th term. So you're going to add 11 common differences, but that's 12 minus 1. It's n minus 1. What do you do to the first term to get the fourth? Well, you add 3 common differences. And my goal in something like this is that you get bored. You go, yeah, I get it. Because if you get it and you get bored, you understand it. That's what my goal is. Sometimes I employ repetition intentionally. Not to put you to sleep, but to drill it into your head. What would be done to the first term to get the fifth? Well, I guess we would add 4 common differences. Now, so for the student who's just looking at patterns here, they're going, oh, well, the second is 1, and then it's 2, and it's 3. It's 1, 2, 3, 4. They might get stumped here because I've skipped a bunch of terms. But to the students who are following, you would recognize you don't need to know how many you add to get to the 22nd to figure out how many you would add to get to the 23rd. To go from the 1st to the 23rd, you add 22 common differences. Because there's 22 steps you have to take from the first position to get to the 23rd. You have to make 22 steps. So you add 22 common differences. So what would be done to the first term to get the nth term? Well, you would add n minus 1 common differences. So before I get to the denouement or the culmination of this, I want you to understand what we're saying so far. And you don't need to write this down if you don't want to. I'm saying that if you want to find the second term, you take the first term and you add 2 minus 1 common differences. And I would like everybody to mentally digest what I've just written. This is saying the second term is the first term plus 2 minus 1 common differences. The third term is the first term plus 3 minus 1 common differences. And I'm hoping that it's sinking in that this number is this number. And if that's the case, then Tn is the first term plus n minus 1 common differences. It doesn't matter what n is. If n is 12, you're finding the 12th term and you're adding 11 common differences because 12 minus 1 is 11. If n is 1,000,000, you're finding the millionth term. We'll come back to that in a bit. Well, we're going to come back to it right now. What's a formula we could use for the general term of any arithmetic sequence? We just did it. It's this thing that I've got written at the bottom. You could use that to find any term, couldn't you? And that's what you're going to write in the box. And that's going to be called the general term. For any arithmetic sequence. Any term, we call it the nth term, is equal to the first term plus n minus 1 times d. So in this formula, whatever T1 is the first term. And D is the common difference. So I'm going to pull up an example that we did yesterday. You could turn back if you want to. I'm going to be talking about the sequence that is on page 1 of the handout, and it is question 3. Okay. You don't have to turn back. I can just write down the important information here. You were given this sequence in question 3, and I'm not asking you to write anything down here. We're just kind of in a informal learning mode right now. And this was early on. We were learning what an arithmetic sequence was, and we said, well, the first term is -4. We may not have even used that notation yet, because I think we were using this to build a table, right? But you now know the first term is -4, and I hope you would agree the common difference is 3. Yeah? And you may see by looking at page 1, or you may remember, that you were told there's a general formula for this sequence that's 3n minus 7. Is that right? Did I write it down correctly? Okay. And remember I put this into my calculator and we saw that it matched the numbers we were getting. And I made a point to you that you don't know where this comes from. But you do now. It comes from this formula that we're talking about. If I take this formula, and where the T1 is, I put -4, And then I write plus n minus 1 times 3. And I simplify that. How would I simplify that? Well, I guess I would have to take the the positive 3 and multiply it through, which would give me Tn equals negative 4 plus 3n, 3 times n, minus 3, 3 times negative 1, and negative 4 plus negative 3 is negative 7. 3n minus 7. You can now use the formula to come up with the general term. Okay, so now let's take a look at some examples with this. What's the general term of this and what's the 40th term? Do you remember yesterday we were asked a question like, what's the 15th term? I don't know if that was the exact question, but we were expected to find like the 20th term of something. And it was kind of complicated, wasn't it? It wasn't an easy thing. Well, this is going to show you that it becomes very easy. The first term here is negative 6. The common difference is 4. I'll give everybody a minute here to confirm that the common difference is 4 and to make sure you know how I'm getting a common difference of 4. I am a number line kind of guy. So when I look at negative 6 on a number line, and then I look at negative 2 on a number line, I can see that I have to go to the right 4 to get to negative 2. And from negative 2 to positive 2, I have to add 4. If you're not that kind of person, then take a term and subtract the term before it. But are we in agreement on these two numbers? Let's load them in to this formula. By the way, the formula will be on a formula sheet. You don't have to memorize this formula. Let's load those two numbers into that formula to get Tn equals negative 6 plus n minus 1 times 4. Now, by the way, right now, if you wanted to find the 40th term, you could do it. You'd take negative 6 and you'd add 39 times 4. Because when you put 40 right here, 40 minus 1 is 39. But we're still expected to simplify the expression and get a final answer for the equation for the general term in simplified expanded form. So we have to multiply this 4 through that binomial. Four multiplied by n is 4n. 4 multiplied by negative 1 is negative 4. And now I have negative 4 and negative 6, which are what we call in math like terms or similar terms. They can be combined by adding them. In this case, giving us negative 10. So Tn equals 4n minus 10. And just to confirm that this works, we don't have to do this. But if well, that's a glitch, isn't it? I don't know what to do with that. There we go. I am going to put in, turn my plot off. There we go. I am going to put in 4x minus 10 and go to my table. And what I should be seeing is that when x is 1, I get negative 6. When x is 2, I get negative 2. When x is 3, I get positive 2, etc. Now, I was playing around with this in my Math 30 class this morning, so it doesn't start at 1. But I don't have to, you remember when we went into the table setting to tell it where to start? I don't have to do that. I can just scroll up. And I can see the sequence. It works. Now, to find the 40th term, You need to understand, and some of you might not appreciate this. You might go, yeah, I get it. But it's going to be backwards later, and it will be trickier later. You need to understand the difference between n and Tn. When I say what is T40, I'm saying when n is 40, what's the term? When I put 40 in for n in this formula, what do I get? So I change this n to 40. I change this n to 40. And I calculate it. 4 times 40 minus 10. Your order of operations says you multiply first. So I believe you get 150, but I want to make sure. Is it 150? So the 40th term is 150. Could we do this? I can't hold the key down on my smartboard, otherwise it thinks I want to right click. Could I do this? Certainly. Could you do that? Yeah. But the more and more you rely on doing things like that, the less and less your understanding of the math is. And later on, it's going to hurt you more and more. This is like, it's been a long day. Let me just do it this way. Any questions with that first example? All right. 1.75, 1.5, 1.25. Well, what's the first term? The first term is 1.75. What's the common difference? I really am almost 100% firing on the assumption that you can find the common difference. We shouldn't even need to discuss this. Take a term and subtract the term before it. Or what do you add to one term to move forward to the next term? And since the term values are decreasing in value, the common difference must be negative. It's negative 0.25. We load those. I'm not going to rewrite the formula. You can see the formula on the screen over on the right if you like, or you can look in your note package. I'm going to load those two numbers into that formula. I might as well introduce this now. These are called parameters. It's not a big deal, but if I introduce a little bit of terminology, a little bit at a time, by the time it becomes important, you are conditioned to it. It's just not really that important right now. Just make a note of it. I put those parameters into my formula, and they give me Tn equals 1.75 plus n minus 1. And watch how I write this. I know even though I'm going to really stress this, some of you are not going to do it, and it's going to cause problems for you. Times the common difference, which I put in brackets. If you don't have the set of brackets, what you're saying is you're going to subtract from n minus 1 the common difference. You're going to subtract 0.25. That's what it looks like. We have to multiply. So now we multiply. Same thing we did before. You distribute that common difference into that binomial, which will give us Tn equals the 1.75. Then we have n multiplied by negative 0.25, which is negative 0.25n. And we have negative 1 multiplied by negative 0.25. Negative times negative is positive. So when we expand that, we get 1.75 minus 0.25n plus 0.25. These two numbers here are numbers. They can be added together. They're like terms. 1.75 plus 0.25 is 2. So we get 2 minus 0.25n. Help me out here. Does this question say for part B we want to find the 40th term as well? So you put 40 in for n and you calculate it. I mean, getting the formula is the math. The rest is kind of just a calculation. But T40 is that. 0.25 is a quarter. A quarter of 40 is 10. So I need to take 2 minus 10. I believe I get negative 8. All good so far? This is a thing of beauty, right? You can solve all of these problems without really thinking about them too much. Example 2. And McKenna, it was you that asked me that question, right? McKenna had asked me a question that we had, did I pronounce your name right? Okay. We wanted to find out 170, what term number was it? Was that right? And the first term was, I better just look back. The first term was -4. Second term was 2. So in this question that we went over, we knew the first term and the common difference, and you wanted to find out which term that was. And we had to do it in a really kind of fractured, awkward way, didn't we? We had to kind of reason it out. Notice that this example we're doing now, number 2, is the exact same question. The numbers are different, clearly, right? We're given the first term. We can figure out the common difference without really too much heartache. And the question now is this. I'm going to approach this differently than I did when I explained this when McKenna asked the question. I'm going to say that unlike the previous question where we had 40 in this column and we were trying to find this, that's what we did in the last example. What we're doing here is this. We know the term value, or we know the term is 220. We want to find the value of n that gives us 220. So the first thing we are going to do is use this, t1 equals 10 and d equals 3, to come up with the general formula. Okay? I'm going to load these into my general formula equation and get 10 plus n minus 1 times 3. And although you can now proceed to finding what n is to get 220, I recommend expanding this out and simplifying it first. Okay? I really think if we do it that way, it's going to be easier for everybody. You will notice that when I did this on the board, I showed less explanation than I did the last 2 times. I will now, to make sure you understand what I'm talking about, show that explanation. I didn't write this. So what you're going to have to get used to is when I do stuff like that, it's to remind you of what you should be doing, but I'm not going to do it all the time. It's like 3 or 4 reminders, and then I might throw in an odd reminder down the road, but you should know. What this gives me is Tn equals 7 plus 3n. 10 minus 3 is 7. So if I want to find the value of n, which is the term number, that gives 220, which is the term value, then I can put 220 in for Tn and solve for n. I think this little table, this chart, is kind of important. This becomes 220 equals 7 plus 3n. And I think if you had a very smart primate, you could probably teach the monkey to solve this equation, if you could communicate with the monkey. I don't mean to be insulting to anybody. I'm just making a point that this is really easy to solve. Right? I better not screw it up now. We're going to subtract 7 from both sides and divide by 3. And I don't know if you remember, but remember when we got 29 and then I said, well, it must be the 30th term in the example we did? You have to think about that, adding what. You don't have to do that. Whatever you get for n is the answer. So I will show this. I mean, I don't know that we really need to show this. What do we get? 213 equals 3n. We divide both sides by 3 and get, by my count, how did I do? 71? It's the 71st term. Well, I guess I should put ST instead of TH, right? 71st. But you get the idea. Any questions with number 2? Let me read this question to you, and then I'm going to ask you a question about it. This says how many terms are in the sequence that starts with -5, -1, comma 3, and then ends with 327. My question to you is, and I'm going to give you a second to think about it, and if the answer to you is yes, it makes sense, put your hand up and down so I know. How many of you see that this is the exact same type of question that we just did? If I want to know how many terms there are, if I knew that 327 was the 40th term, then I guess there would be 40 terms, wouldn't there? Because it's the last term. This is a really important idea, that if you find n for the last term, if you have this kind of idea floating around your head, and you get a number here that gives you the last term, then this number is how many terms? Because it's the term number of the last one. So if the last one's 100, then there's 100 terms, because that's the last one. So this question is the same as the one we just did, the same as the one that was asked about when we went over the homework, but it's got a different mask on. It appears different to us. Bottom line is, what value of n would produce 327? So we take -5 as t1, we take 4 as d, we load them, everybody, into this formula and simplify it, and that's what I want everybody to do right now. I'm going to write it out with the numbers in, and then I'm asking everybody to take a minute or two and simplify it. So we will get Tn equals T1, which is -5, plus n minus 1 times 4. You have to simplify that. And it's really not a difficult thing. By a show of hands, how many of you would probably simplify it in one shot and just write it down? Just be careful. Because when you do that, and I would as well, but I do roll the dice from time to time, and I will make a mistake by not showing a step in my head or on paper. So anyway, I'll give you a minute to do that. Yeah. I mean, it's just, and by the way, just because I say something like, oh, this is grade 9 math or grade 8 math, doesn't mean you're not going to make a mistake from time to time. We all make mistakes. It'd be a weird world if nobody did make mistakes. But 4 times n is 4n. 4 times -1 is -4. -5 and -4 is -9. So I get that. Nobody's asked, could I write this? Do you think I could write that? Yeah. I typically, though, if I have a negative, I won't write it as the first term. I'll put it afterwards. Now what we're going to do is put 327 in for Tn. And again, I don't mean to minimize things and go, well, it's so simple, you'll never get it wrong. But this is a pretty easy equation to solve for n. You add 9 to both sides and then divide by 4. What was that? 436, that's 75, and I want to say 75 and 9 is 84. Is that right? And by the way, when I do that, and I say, is that right? That's because I'm probably, well, I'm right a lot of the time, but sometimes I'm wrong because I'm doing it in my head. So use your calculator. Add 9 to both sides, I get 336. This is equal to 4n. Divide both sides by 4, and you get n equals, what did I say, 84? So if n equals 84 gives 327, and 327 is the final term, then the final term is the 84th term. There must be 84 terms in the list. Any questions with that one? All right. So an arithmetic sequence is defined by 2n plus 4. Sketch a graph. So I guess what we want to do, since I have n on the horizontal axis, is I want to start calculating different values of Tn, which goes on the vertical axis, for various values of n. And quite frankly, I don't care how you get these numbers. You could write out 2 times 1 plus 4 and put it in, 2 times 2 plus 4 and put it in. You could put 2x plus 4 in for y in your calculator and go to your table. When I put 1 in for n, whether I use my table, mental math, Smarties to count and multiply, I'm going to get 6, correct? When I put 2 in for n, I'm going to get 8. How many of you know why the common difference has to be 2? Why is that, Will? 2 is the coefficient of n. So every time n goes up by 1, you're adding another multiple of 2. So when you go from 5n to 6n, or when you go from putting in n equals 5 to putting in n equals 6, you're adding an extra 2. So I don't think I really need to explore this much more. This would be 10, this would be 12. And that means that we're going to have a point here. When n is 2, we are at 8. When n is 3, we are at 10. When n is 4, we are at 12. I don't know. We can keep going. I hope you see, this is going to be one of the most important aspects of what I've got here, that these dots, we go from one dot and we move 1 square to the right and 2 squares up. Because each time you increase by n, by 1, you add a common difference, which is 2. Not really important in terms of the course, but how many of you see that the slope that these dots form is 2? 1, 2. 1, the rise is 2, run is 1. How many of you remember from grade 10 that an equation that looks like a number times x plus a number has the slope that's equal to the coefficient of x? I hope everybody, actually. The slope of the line is going to be 2. Every time you go up by 1 horizontally, you'll go up by 2 vertically. There's a nice connection here. Okay, don't do anything, just watch. Have I done anything wrong in this question? Is there anything on the board right now that's wrong? I'll give you a hint. Yes, there's something seriously wrong. Not anything you're going to have to erase. Go ahead. But it's linear, isn't it? Why should I not draw a line? Right. And the word for that is discrete. You cannot have, I can have a first term and a second term and a third term. Can I have a 2.48th term? No. So by connecting these dots, which is why I told you don't draw that, you would be making a serious mathematical mistake. This is not a continuous situation. And I don't know how many of you remember, I'll ask, how many of you do remember these words continuous and discrete from grade 10 math? And it's, you know what, it's probably told to you in the course of a lesson, and then you move on. You never really revisit it. But discrete would be, well, I'm old school. If you took a cab, the fare you pay is discrete. You get in and the cab says $10 and it drives, and all of a sudden it says $11, and you drive and it says $12. It doesn't go up continually. It's like a digital clock. It goes from this time to that time. That's discrete. Continuous would be like if I had a jug of water and I poured water in and I talked about the volume of water. It's continuous, right? It doesn't go from this much water to this much water without being in between. So we don't want that line. What's the significance of the graph being linear? The significance is that there's a common difference. That's it. That you go up by 1 for a term number, and you always go up by the same amount for the term, for the addition to get the term value for the next term. So it's a constant slope. It's a common difference. And I don't know, everybody, really how important that is in terms of learning or in terms of exam questions, but I think it is important that if you see a graph that looks like that, you know that it's arithmetic. But if you saw a graph that looked like this, you would know it's not arithmetic, because it's going up by a certain amount from T1 to T2, and then it's going up by a different amount in going from T2 to T3. I think the conclusion here that linear means arithmetic is important. Okay. Any questions with that example? All right, now the final example. This is your first foray into something where all of a sudden it's algebraic. We do not have numbers to deal with. And this should take us around maybe between 5 and 10 minutes, which will mean you'll have about 20 minutes to work on today's practice. The first term of an arithmetic sequence is 4x. It's not a number. It's an expression. And the common difference is negative 5x. What does that mean? Let's write out the sequence before we do anything. The first term is 4x. The common difference is negative 5x. What does that mean? It means that you add negative 5x to get to the next term. So if I had $4 and I added negative $5, I would have negative $1. I'm $1 in the hole. I'm playing poker. I'm $4,000 ahead. I bet $5,000 and I lose. I'm $1,000 down. If I had 4 as a golf score, and then on the next hole I had -5, which would be incredible, then I would have -1 as a current score. If I had 4 kittens and I subtracted 5 kittens, I don't know how I got rid of them, but I subtracted 5 kittens, I'd have -1 kitten. I'm pointing out to you that 4x plus -5x is -x, which is something that you should know, right? It's -1x. And if I add another -5x, or subtract 5x, I guess we could just say, I'm going to get -6x. And then I'm going to get -11x. And then I'm going to get -16x. Are you with me here? That this is arithmetic. It's just that we don't have numbers. We have numbers combined with letters. That's all. So what's the general term? Don't forget, this is the general term. Look up here, general term, Tn. That's what we want to find. So we're going to load in the first term and the common difference into Tn equals T1 plus n minus 1 times d. Just because it's not a number doesn't mean we don't do the math the same way. You do the math the same way. It's math. I may have said, or I may not have, in math, the stuff we write down on paper are just a bunch of squiggles. Have I said that to you? I think I said it yesterday. They're just a bunch of squiggles. This squiggle means 8. This squiggle is the proverbial X that you're always trying to find. These things are all squiggles. It's the operations on them that are math. The squiggles represent things. So T1 is 4x. What does that mean? It means T1 is 4x. If you said to me, well, no, Mr. Way, seriously, what's the value of T1? I'd say it's 4x. It's not a number. Plus n minus 1 times the common difference, which is negative 5x. Make sure you put that in brackets. What did we do when the first term and the common difference were numbers? Well, we multiplied the common difference in and then collected like terms. We do the same thing here. Negative 5x multiplied by n is negative 5xn. Some of you might write negative 5nx. That's fine, because the order in which you multiply things doesn't matter. That being said, I probably wouldn't write negative n 5x. I'd put the 5 out in front. And then negative 1 times negative 5x is 5x. 4x plus 5x is no different symbolically than adding 4 puppies plus 5 puppies. If you add 4 puppies plus 5 puppies, other than a great deal of happiness, what you have is 9 puppies. So 4x plus 5x is 9x. Tn apparently is 9x minus 5xn. That's it. Look, why would I give you a question like this? Why would we be doing a question like this, which really has no application? Because if you said to me, when will we ever do this? When will we ever use this? I'll be honest and say never. You go, well, why are we doing it? Here's my honest answer. To build your mathematical muscles. To get better at algebra. Okay, that's the bottom line. What else do we got to do here? What's the 12th term? Well, we know that the nth term is 9x minus 5xn. Did I remember that right from what we just did? Okay. In question B, n is 12. We want to find Tn. So what we're going to do is put 12 in for n and figure out what we get. Didn't leave myself a lot of room here. I apologize. Let me fix that. 12. So I'm putting n as being 12, and I wrote it in for an x when I should have put it in only for the n. And, well, let me write out what should be 9x minus 5x times 12. And I'm not making excuses, and I will never make excuses or apologize for making a mistake. I'm pointing out to you that you will make mistakes. If I make mistakes, and I've been doing this for as long as I have, you're going to make mistakes. I've met very few students who get 100% on everything. They exist, but they're rare. 5 times 12, is that better? We're okay now? I apologize for that. 5 times 12 is 60, is it not? So rather than writing 5 times x times 12, I can write 60 times x, which means we get 9x minus 60x. Well, $9 minus $60 is negative 51. So 9x minus 60x is negative 51x. Any questions with B? All right. Which term is equal to negative 126x? Well, in this particular question, that's what the question is. When the term value is negative 126x, what's n? No, what's interesting here is you might be a little confused by this, because if I put negative 126x up here for Tn, let me write it out. Negative 126x equals 9x minus 5xn. So I've just replaced Tn with negative 126x. Many of you will look at that and go, well, I can't find n because I don't know x. There's too many unknowns. Who has the solution to that quandary, to that problem? What can I do here? Yeah. I can. I'm going to divide both sides of the equation by x. An equation should be thought of as like a teeter-totter or a seesaw that's in balance. As long as whatever I do to one side I do to the other, it stays equal. It stays in balance. So if I divide both sides by x, which means I divide this by x, and this by x, it's still a true equation. There are other ways that we could explain how to get rid of those x's. We could, just in a loose way, say, well, if every term has an x, we can cancel the x's. That's maybe not as good as saying, let's divide both sides, or divide everything by x. What happens here is cancel, cancel, cancel. And as a result, we're left with a pretty basic equation that we can solve. And I know I talked a little bit about this yesterday, but I want to spend a little more time today with it. I think it's to your advantage whenever you're solving an equation for a variable, as a first step, to move the term with the variable to whichever side makes the term positive. Okay? In other words, I don't think it's a good idea to do the following. Don't write this down. There's nothing wrong with it. I don't think it's a good idea to do this. And then divide by negative 5. It works, okay? You get the right answer. What I'm saying is, it will help you later if you get in the habit of saying, since n is in this term here, which is negative, I'm going to add that term to the other side, where it will be positive. I'm going to move the terms back and forth across the equal sign so that I have the term with the unknown in a positive position. The 9 we leave alone, and the 126, if I move over, gives us positive 126. I hope you see the results the same, except instead of having them both negative, they'll be both positive. Anyway, I get 5n is equal to 135. I want to say 27. Is that right? When I divide both sides by 5, I get n equals 27. So the 27th term is negative 126x. Was that what it was? Negative 126x? In the question? Yeah. So that's the 27th term. Any questions with that final example? Okay. Again, that final example is more about building those algebra skills. It's not, I mean, it's something that you could see on an exam, but it's not the big deal. First of all, I changed the assignment slightly. It says on page 17, 7 to 10, but in question 7, don't do D or E. And it's only because they're so poorly worded, I don't want to have to explain it. It's a mess of what they're trying to teach you. So, and then there's 8, 9, and 10, and then a few questions on page 66. we're kind of reaching the end of this topic of arithmetic sequences. We'll finish it tomorrow. If you were to go near the back of your handout, there's boatloads of extra practice stuff. So something that students will often say is, Mr. Way, I get this, but do you have any extra practice? It's already there. Okay. So there's a section on arithmetic sequences there as well.